Do you know how a hot air balloon is able to fly despite being so massive? Charles' law states that with an increase in the temperature of the air, the volume of the air will also increase. Therefore, as a result, the density of the air contained in the envelope of the hot air balloon becomes lighter than the density of the outside atmosphere. Hence, due to buoyant force, the hot air balloon is able to fly.
Assalamualaikum warahmatullahi wabarakatuh. I'm Idlan, and today I will be presenting about Charles' law. This presentation was made by my group Wafi, Aish, Amirul, Alina, and Shafika, with some help from our mentor, Teacher Zila. According to the Charles' law, volume is directly proportional to the absolute temperature for a fixed mass of gas at a constant pressure. Over to the right, you can see some formula that is often used for this topic. T is for absolute temperature, that is Kelvin, and V is for volume of gas. In the graph shown, the volume of gas is directly proportional to the absolute temperature. The graph shows that if the temperature is in degrees Celsius, the graph does not pass through the origin. Here is a table of formulae for this topic. T is absolute temperature, Kelvin, while V is for volume of gas in m⁻�3. When the temperature increases, kinetic energy of molecules increase, and so the molecules will move at a higher velocity. The air molecules move faster and collide with the wall of the container more vigorously at higher frequencies. As a result, the space between the gas particles increases and the volume of the gas increases. Remember, when the temperature increases, the volume also increases. Do you remember the hot air balloon from earlier? That's one of the many applications of Charles' law in daily life. Parts of a hot air balloon basically consist of an envelope that stores heated air, a burner, and a basket or gondola to carry passengers. When the fuel source is ignited, the air contained inside the envelope gets heated up. Because of Charles' law, the volume of the air will also increase. Therefore, as a result, the density of the air contained in an envelope becomes lighter than the density of the air outside. Hence, due to buoyant force, the hot air balloon flies. The next example is the bursting of a deodorant bottle. Have you noticed that every deodorant bottle has a warning label that says to keep it out of direct sunlight? This is why. Under high temperatures, the gas molecules inside the deodorant will expand. Therefore, if it gets too hot, it will explode. The last example is a helium balloon on a cold day. A balloon will shrink if it gets too cold. Why? Because of Charles' gas law. When the temperature decreases, the volume of the helium gas inside the balloon will also decrease. This also works vice versa. Therefore, if you bring the balloon back into a warm room, it will retain its normal shape. Here's a question. The figure shows some air trapped in a capillary tube. Given that the temperature of the air is 27 degrees Celsius, find the length of the air column when the temperature of the air is increased to 87 degrees Celsius. Firstly, you must list out all the information given from the question. The first temperature we get is 27 degrees Celsius, while its volume of gas is 6 centimeters. The second temperature we get 87 degrees Celsius, and we don't know what the volume of gas is, and that's what we're looking for. The second step is very important, and that is to convert the temperature from degrees Celsius to Kelvin. To do this, you simply add 273 to the temperature. This is because at 0 degrees Celsius, you get 273 Kelvin. For the first temperature, we get 300 Kelvin, and for the second temperature, we get 360 Kelvin. The last step is to substitute the information into formula applying the Charles' law. After doing all the calculations, you will find that the length of the air column when the temperature of the air is increased to 87 degrees Celsius is 7.2 centimeters. Remember to change the temperature from Celsius to Kelvin for your calculations. Question 2. State Charles' law. The answer: Charles' law states that the volume of a fixed mass of gas is directly proportional to its absolute temperature if the pressure of the gas is held constant. Question 3. A plastic bottle which contains hot air is put into a basin of ice as shown in the figure. Study the figure carefully. This situation can be explained by A. Boyle's law, B. Gay-Lussac's law, or C. Charles' law. The answer is C, for Charles' law. Why? Because the volume of the plastic bottle is reduced when its temperature drops, which is in accordance with Charles' law. Now for the last question. Diagram 10A shows a cylinder which contains gas at the same pressure as the air outside. The piston moves freely along the cylinder without any friction. No gas escapes. The initial height of the piston is h centimeters. As the cylinder is heated, the piston moves upwards. The new height of the piston is 2h centimeters, as shown in diagram 10B. The initial temperature of the gas is 30 degrees Celsius. If the pressure remains constant, what is its final temperature in degrees Celsius? Here's how to solve the question. First, list out all the information given from the question. The initial temperature is 30 degrees Celsius and the final temperature is unknown. The first volume is h centimeters and the second volume is 2h centimeters. The second step is to convert the temperature from degrees Celsius to Kelvin. The first temperature is 30 degrees Celsius, so we get 303 Kelvin. The third step is to substitute the information into formula, applying the Charles' law. After doing all the calculations, the answer you should get is the final temperature is 606 Kelvin. The final step is to convert back the Kelvin into degrees Celsius. This is important because the question explicitly states to give the final answer in degrees Celsius. Therefore, 606 Kelvin becomes 333 degrees Celsius. That's all from us. Thanks!